Hello and welcome to today's video. Today we're going to talk a little more about systems of linear equations and solvability of these systems. In particular, we already had a look at the number of pivots, and we're going to define a name for that number of pivots. That's going to be the rank of a system of linear equations. And then we'll explore the connection of this rank with the question of whether a system of linear equations has a solution or not. We'll revisit that idea later on. We talk about matrices. For now, we'll only investigate systems of linear equations. So this section is called rank and solvability of a system of linear equations. And let's define that rank first. So, as I said already, what we need is a system of linear equations. And let's just define that in Tableau form. So, for a system of linear equations in Tableau form, that Tableau is of the form we have the coefficients A, and we have a right-hand side that we call B. Let R be the number of pivot elements in its echelon form. Then R is called the rank of the coefficients. Does not depend on the right-hand side, so we don't really need that right-hand side for the definition. The rank only depends on the left-hand side, on the coefficient side. So R is called the rank of the coefficients A and is denoted as R equals rank of A. So also in this notation, we omit the right-hand side B because it does not influence the number of pivots. Only the coefficients on the left-hand side are important for that. Now, what does this rank have to do with the question of solvability? Of course, the right-hand side plays an important role here. And what we can do is we can compare the rank of the coefficients A with the rank of the coefficients that we get by just extending that A by one more column, which is the right-hand side. And the idea basically is if we have a zero row in echelon form and the right-hand side is non-zero, that means there is no solution. Now, if we regard this left-hand side coefficients plus that one column as one system of coefficients and determine its rank, then of course that will be larger because this non-zero element on the right-hand side would now count as a pivot element. But that new system would have one more pivot element. And that means the rank would not be the same. In that case, we don't have a solution. If the rank, on the other hand, does not increase if we add that one column, then we do have at least one solution, and we can even characterize the cases where we have a unique solution or more than one solution. So That will be the theorem here. It connects the cardinality of the solution space to the notion of rank. So let A, B be a system of linear equations in tableau form with, say, we have m equations and n variables. And let S be its solution space. Then the following hold. Now, first, as I said already, if the rank of the coefficients A is not equal to the rank of A extended by that one column B, and what we mean here is we take A and we just write one more column next to it. We take this extended coefficient set, then the solution space is empty. So in other words, we have no solution. If the rank is equal, then there's two possible outcomes. First one is if rank A equals rank of A comma B, and that rank is n, the number of variables. Then the cardinality of the solution space is 1. Or in other words, the system does have a unique solution, just one single point. Or in other words, there's no free variables. And finally, the case of free variables. If the rank of A is equal to the rank of AB, and that rank is strictly less than n, then there is a solution, and it has n minus rank A free variables. We'll also say that the dimension of the solution space is n minus rank of A. And what that means is that there is more than one solution. Okay, so that characterizes the cardinality of the solution set, or at least partly the cardinality of the solution set, by looking at that rank, at the number of pivot elements of the coefficients and of the coefficients extended by the right-hand side. What we are going to do next is we're going to investigate the structure of that solution set a little more. We want to know if it has a certain structure, maybe a certain geometry, and how that depends on things like the rank or maybe other things that we can find out about our coefficients on our right-hand side. We'll deal with that in some of the upcoming videos. So I hope I'll see you then.